The Preston bike is John's baby. It represents a radical departure from traditional cycle design. Constructed from aircraft-grade aluminium, its unique suspension system is designed to preserve the rider's body and sanity when they do things like this.
It was when I was working in Formula One, designing suspension systems like this, that I came up with the idea for the bicycle suspension system like this. And you can see it works like that, it moves up and down. And you may not believe it, but the Formula One suspension system is exactly the same as the bicycle one, in that we have a top wishbone here and a top wishbone here. We have a lower wishbone here and a lower wishbone down there. And it moves in exactly the same way. It's just that if this was a Formula One suspension system, the wheel would move around an axle that way, whereas we've turned it through 90 degrees and got it that way. But it's basically exactly the same.
By using the same 4 levers on bearings, but twisting the wheel around, John thought he had a great design idea. But turning the idea into reality is where the job of the design engineer really starts.
After I left Benetton, we set up this workshop here in the Cotswolds to design and prototype our bikes. And over here, we've got the very first bike I ever prototyped. It feels a bit heavy now. We've moved a long way since then. And then here, we have a little Meccano model I built. When I first came up with the thought for this front suspension system, I had to try and prove that it would work. And so I built this little Meccano model that shows that you can have steering and suspension at the same time.
Once you begin to put suspension on a cycle, it starts to get heavy. The last thing you need when you're riding off-road is an unwieldy bike. So, John had to complement the suspension system with the right kind of frame.
Now, obviously, to make a bike frame, we've got to choose a material. And the 2 most important criteria are that it's got to be light and it's got to be stiff. So here we've got a piece of wood that's fairly light, it's fairly stiff. So let's see how strong it is. Not really very strong, so I think we'll have to disregard wood. Aluminium's a nice light material. It's pretty strong. Very light. How stiff is it? It's not stiff enough. So what can we... Oh, I know. Let's try and make it thicker. So here we have a nice thick bit of aluminium. It's strong, and it's very, very stiff. But how are you going to pedal that up a hill? You know, it's far too heavy. So what else can we do? Well, maybe if we take this and form it into a shape and make something like this, which is a monocoque construction, then we end up with something that's very light, very strong and very stiff.
Monocoque is one of those technical terms for something which is really quite simple.
Basically what we do is we take this thin sheet and we form it, we bend it and give it stiffness. So we end up with a shell like this, and this is just this piece of metal turned into a skin like that. And we go from this, which is very flexible, to this, which is very stiff. If we then take another one of these and weld the 2 skins back to back like that, we take 2 things that are very stiff and make them into something that is even stiffer. And here we have, once we put the centerline welds in, we end up with a monocoque frame like this, which is very stiff, and it's called a monocoque because it's a single skin.
Creating the monocoque frame in the first place was a question of trial and error. So, with the simplest of tools, John makes his own prototypes in his own workshop. The final stage was to refine the prototype. For this, he and his assistant, Nick, turned to computer-aided design. So, sum it up, Nick.
Once we've finished designing the prototype, computer-aided design CAD system, 3-dimensional picture, looks good. Email them various manufacturers, CAD file, CAD CAM, computer-aided manufacturing. Make the part, should work all right.
With the components assembled, John and Nick can finally test the bike and its suspension.
No